Alright, so take two. We'll do a quick recap of what we've done on Friday. So we started looking at tangent property. So the first one, still haven't quite got this proof out yet to show you. But the property, we'll take this as an assumption for the time being. The radius is perpendicular to the tangent at the point of contact. Okay. Number 12, we have an external point and we draw tangent to either side of the circle. Those two tangents are equal in length. Right, 13, so where two circles touch, okay, at the point on the circumference where they touch, if you draw the interval between the centre points, okay, they'll also go through the point of contact. And we showed that by doing the tangent and showing either side is the right angle, and therefore those two right angles add up to a supplementary angle, which makes OCP a straight line. And number 14, so I've already mentioned this before, is probably one of your more common properties that you're looking for when you're doing questions. One of the more common ones that does turn up more frequently than others. Okay, so we have a tangent. Okay, and then we have a chord. The angle that's formed between the chord and the tangent. So where we have the chord, we have a common point on the circumference. We join up the end of that chord to that common point. It also equals that angle in there. Okay, angle in the alternate segment. Okay, so in other words, it is opposite the chord. Again, so you've got the tangent, you have the chord here, you've got the angle formed here. The opposite angle from that chord is also equal to that angle in there. Okay. So we need to make sure we're looking out for that in our proof. Right, the last one, where I did warn you that the proof is quite detailed in terms of similar triangles and matching the size of those similar triangles. Okay, but the principle is the square of the length of the tangent. Okay, so the tangent from the external point to the point on the circle, we square that length. It equals to the overall secant length. Okay, multiplied by the external point to the first point of contact to the circle. Okay, so you need to remember that formula. T squared equals the overall secant length multiplied by the external point to the first point of contact to the circle. Right, so today we're going to go through these 4 examples. I'm going to give you the rest of the lesson to get through. We'll start wherever you're up to in exercise chapter 9 exercises. So what that means by Wednesday term 1, ready for our first class, okay, I'd like you guys to be up to date as much as you can, ready to continue, okay, because you'll still have a week after I finish the topic to get all exercises done, so please be spending some time and getting yourself up to date as best you can, so you're not further and further behind. Right, question A. So we need to show that AB, the interval AB, or the line AB, is parallel to CD if AB and CD are both tangent. So we need to show those two lines are parallel. How can I do that?
UPO is a straight line and they're perpendicular.
Yep. Yep. So we got perpendicular lines there. So we mean we've got some right angles involved there. How am I going to use those right angles to show that those two lines are parallel? Alright, so if I show that there's a right angle there, and I also show there's a right angle there. The C1 can also work. So if I show the angle here, for example, I can do that. Okay, but why I've done these two, because they're alternate angles. Okay, so we have our Z shapes there. Okay, so when we have angles equal, when we have the Z shape, therefore the lines must be parallel. Right, so let's show it. Alright, so today's date. Happy April Fools to everybody. We're up to the example.
actually have something to think about this, don't it? That's ridiculous.
This is on page page 103 of your notes. Right, so we need to show those two angles. So angle BPO or BPQ or any other valid notation there. Okay, will equal 90 degrees, and also angle CQP is 90 degrees as well. Okay, and we need to state a reason. Radius is perpendicular to tangent. Okay, which then implies that AB must be parallel to CD. And the reason we have alternate angles are equal. Okay, so we refer to the alternate angles there. We state they're equal. We state they're parallel because those angles are equal. Right. So when they're equal, the line's parallel. Alright? So you can always have alternate angles. You can have two intervals drawn with a transversal through them. You still have alternate corresponding co-interior angles. Only if those two lines are parallel, we have the properties of equal and supplementary. Alright, B. Right, size of angle L, M, N, this one. Okay, that angle there. What's the size of it, or how do I work out the size of it?
The last trick will be the really tricky one.
Yeah.
The opposite angle, so MLM is going to equal 42.
Yep,
And then
good. So that 42 here.
can you do in angle sum?
Good, okay. Or what's the alternate way we could work it out? Okay, if I was able to work out this angle here, I can then go to my property there, alright? That's the alternate way we can do it. Okay, so work out the angle sum on a straight line, and then go vertical opposite. Alright, but we'll do it Robin's way. Alright, so make sure we're setting it all out properly. Angle N, L, M is equal to 42 degrees. Right, reason. Angle between chord and tangent is equal to angle in alternate segment. Okay, so make sure we're writing down these reasons every time, please, so that we are learning them, we are memorising them, and we're getting good at them. Sandra Lynch in Year 12, she's the only Extension 1 student in that class.
Is there a second?
Okay, there's no Extension 2. And she's having major difficulties with this topic, okay, because she's not one that's very comfortable with this. So one of the things I'm doing to help you guys, to help you to remember it for long term, because you've got to remember this in your HSC as well, is to write down the reasons every time, okay? So hopefully what that will help you to do is reading becomes second nature, okay? You also, we will be doing this in the HSC course, quick summary of the rules, and then focusing more on your deductive reasoning side of things as well, okay? Right, so therefore, angle LMN is going to be 180, take away 42, take away 73. So we got 115, 120, so that'll be 65 degrees. Alright, and make sure you state reason. Angle sum of triangle is R. Okay, Matt and Cooper that did the HSC last year, they did extension 1, okay, they also had a bit of difficulty with remembering these. They remembered some of them, just in terms of trying to remember as many as you can. It is a big ask, I understand. Okay, but the better you set up this work here and memorise them by writing down your reasoning every single time, the better you will be at them, and hopefully you'll be able to answer the circle geometry question, because I can pretty much guarantee there will be at least one question, at least 2 or 3 marks in your exam based on these principles, okay? Alright. See. Right, so PQ and PR are tangent to the circle. With centre O and radius 11.5 centimetres. So we should put in that information in there. 11.5. What happened there? OP is 29.9. 29.9, so labelling this in the diagram as best you can. Find the length of PQ and PR. Okay. What can you tell me about PQ and PR in relation to each other? Equal sides. So how we need to find, how we're going to find the length of those two sides. Pardon? Good. Okay. So we are given the angle opposite the right angle to the hypotenuse. So that's the one we are given. So we have to find the length of the shorter side. Okay. So let's set it out. Right. So first, let's state that we know that PQ equals PR tangent drawn from external point are equal. Okay. Right, so PR squared is going to be PO squared take away RO squared. We're setting up Pythagoras. You don't need to state the formula, however, it's probably a good idea to help remember it. So it's going to be 29.9 squared take away 11.5 squared. And you could probably do this. PR is the square root. Alright, so I have talked about in your equations that when you take the square root, we have two possible answers. We have the plus and the minus. Okay, when we take the square root and we are finding distance, okay, we're always taking the positive square root. So what we need to get in the habit, the negative square root neglected. Okay, because we're finding distance. All right, since distance. Okay, the distance always represented the positive number. When you do physics and talk about displacement, have you talked about that yet? All right, you can have negative displacement. All right, so displacement and distance are two different things. All right, and you're doing a fair bit of that sort of stuff in your HSC course as well. All right, so square root 29.9 squared, take away 11.5 squared, 7.6. Right, what else do I need there? Units, okay, but we're given them, so we need to write centimetres. So therefore, also PQ is 27.6 centimetres as well. Okay, so making sure when you answer the question, or when you think you have answered the question, you go quickly and look back to the question itself and make sure you've answered it. So you said find the length of PQ and PR. Alright, so I'm just making a quick note. Alright, I'm just going to write that down so I have answered the question. Even though, yes, we set up here PQ is PR. Alright, I wouldn't penalise you if you didn't write this, because you told me already that PQ is PR. So just making sure in case you get a very nitty, picky marker in your HSC. Alright, D. Right, so we need to find the length of the tangent AB in the following ratio. So this is the following diagram. This is T. Right, remember the whole thing here? That's A.
I know this one. AB squared equals 60 times 20.
And this little bit is B. So nope. T for tangent. Alright, so so the length of the tangent squared is equal to the whole length of the secant from the second point of intersection multiplied by the external point to the first point of intersection. Okay? So, write down your formula. T squared is A times B. Right, we are finding the length of the tangent. How long is the secant? 80, the overall length of the secant, multiplied by the external point to the first point of contact of the circle. Okay? So, T is going to be just the positive square root. So 8 times 2 is 16, and then 2 zeros. I'm pretty sure that's 40.
We guess.
Alright, you are specifying a distance. You are not told any unit, so you need to write units here. Okay, neglect negative square root since we're finding distance. Okay, so we need to get in the habit of saying that, because there will be times that you will take the square root of things in real life scenarios in terms of doing maths and real life examples in the world, and you'll have to neglect wanting a solution. All right, so we'll get in the habit of that.
I'm looking forward to the point where it's, you have like
All right, so that covers up to and including exercise 9.4.